Dr. Oberheide, it's a pleasure to have you today. I would like to start if you could tell us a little bit about what you studied, where you're from, and what brought you to Clemson and what you teach here.
So I'm a physicist. So I'm a professor in the Department of Physics and Astronomy. Came to Clemson 7 years ago in 2010. My scientific interest is called space physics. It means I'm interested in, speaking in physical terms, in the fluid dynamics and plasma physics in Earth's near space environment, or in other words, I'm talking about everything in the atmosphere that's between 100 to 400 kilometers above ground.
Okay.
And to put that into perspective, 400 kilometers is approximately where most of the unmanned and manned space flight takes place around Earth. So it's a part of, it's still called atmosphere, the upper atmosphere. It's a part of the upper atmosphere where we still have a large number of air molecules left, and also ions, charged particles, so that changes in little wiggles, changes in how many particles, air molecules we have, actually has quite a bit of an impact on satellite orbits and also on satellite operations. So that's in the end the reason I moved from Germany to the US, because the US, particular NASA, actually has a very exciting space exploration program that fits very well with my own personal scientific interests.
Okay.
And it's not the first time that I moved to the US, so I got all my basic higher education from the master's degree to a PhD in Germany. Okay. Got my PhD in 2000, and then I moved to Boulder, Colorado, to the National Center of Atmospheric Research. Spent there 2 years as a postdoc, and then moved back to Germany as a research professor. And as I've said, 2010 I came to Clemson.
Okay, yeah. So I was learning how to drive then. But okay, so as far as that research goes, to somebody who doesn't know a whole lot about, physics or, what you're studying, could you explain how that relates to space exploration?
So the field of my study is called heliophysics. So it's one of the 4 scientific research divisions in NASA, for example. So NASA has Earth science, which is climate research. It has astrophysics, which looks into the universe. It has planetary science, which looks into planets like Mars, Venus, Jupiter, and so on. And heliophysics looks into what does the sun do to Earth.
Okay.
So if you have a big explosion on the sun, it's called a solar flare or coronal mass ejection. So very technical terms. In the end, that means a lot more of radiation, hard radiation, X-rays, charged particles, electrons, protons actually hit Earth's upper atmosphere, and this can really mess up things. That's a part I'm mostly interested.
Okay, so you're interested in, as you said earlier, the particles coming around the Earth and hitting those satellites. Okay, and how to diverge from that. Now you said that satellites, you talked about the drag, that, you have 2 options. You can avert these particles by creating a drag or using the propulsion system. Are those the only 2 options that you have?
Well, so talking about particles, let's first talk a little bit about space debris. So in the low Earth orbit, so roughly 400 kilometers above the ground, we have about 1,100 active satellites around 1,500 old satellites that do not work any
And
longer.
these are from various countries,
These
correct?
are from various countries, mostly from the US, the former Soviet Union, the Europeans, the Chinese, the Japanese, and so on. But in addition to these satellites, we also have a lot of tiny little leftovers from previous rocket launches or satellites. This is called space debris. And there are about 500,000 space debris pieces that are the size of a marble or a little larger. Okay, and best estimate is something around 100 million smaller pieces. That's so all these little pieces travel with approximately 17,000 miles per hour. And if one of these pieces, let's say size of a marble, were to hit a satellite, this satellite is destroyed. Because it's pretty much the same effect as firing a grenade into a satellite, because these pieces travel so fast. So that means an absolutely critical task for technological society, and critically important for for the commercial space industry, for example, is to make predictions if one of these little space debris pieces is going to hit a satellite.
Okay.
Because if there's a certain probability to hit one of these satellites, you better move your satellite out of the way, if you can do that. So because we are talking about pieces of hardware that cost between 100 million to north of a billion with a B. And of course we have the International Space Station, which is manned with astronauts on boards, which would be particularly bad to be hit. But a satellite operator has to make a decision. If someone tells the company, well, you have 90% or 10% probability to be hit over the next few days, do I need to move my satellite out of the way? There are different ways to do that. So if you have a satellite with a little engine on board, rocket engine, propulsion, okay, you move it out of the way. But in the end, you don't really want to do that, because there's a reason that you have your satellite at a particular place. And if you move the satellite, well, you cannot use it, so you are losing money, because that's your whole business model.
Absolutely.
To have the satellite operational. If you have a smaller satellite with no propulsion on board, you can still move it out of the way by changing a little bit the orientation of the satellite. It's like using the whole satellite as a sail. So that means you can also change your orbit a little bit, move it out of the way, but there's no way that you can actually bring it back into your original orbit.
That's a problem.
So that's really not something you want to do.
Yes, sir.
What the space industry really wants to have is a good prediction, or much better predictions we have right now. That's because right now they give you a 50% probability to be hit. What do you do?
Yeah, okay. You want more certain.
So you want more certain predictions over 3 or 5 days to actually make the call. Do I need to do that or not? So we are talking about a lot of money.
Absolutely.
Here.
Okay, and so any of your past projects or your current research, have they been funded by NASA in particular? Yeah,
I have 3 active NASA research grants. So I'm a tenured faculty, so I have a 9-month salary from the university, but NASA projects pay a substantial part of my summer salary, and my opinion, more importantly, they also pay for my graduate students.
Absolutely, so they pay for your graduate students' studies and their research as well.
Exactly. So I couldn't support my graduate students without that.
Absolutely. Okay, so as somebody who receives, funds from NASA, How do you feel about their $19.3 billion budget? Do you think they should increase it, decrease it, or remain the same, or how do you feel about that?
Well, 19.33 billion, to put this number into a context, that is less than 0.5% of the federal budget. That means for every tax dollar, we spent about, or less than half a penny of every tax dollar for NASA. So the income tax contribution to the federal budget is less than 50%, if I remember correctly. So in the end, every taxpayer pays less than a quarter of a penny for every tax dollar he or she sends to the federal government.
Absolutely, yes, it's
so
nothing.
It's really not a lot of money for an individual. And if you look into what NASA actually delivers for that, that is a lot.
Yeah.
That's so in terms of discovery, space exploration, so all the missions to the different planets, all the satellites and telescopes that look into the universe. So the Hubble Space Telescope, which will be replaced in 2 years by a much bigger one. All the climate research that is done, and I'm a scientist. I actually believe in climate change.
Absolutely, yes.
So I want to make that clear. So we couldn't do that without NASA research and the NASA satellites, obviously in my own field. So that's the scientific discovery curiosity level, and for an advanced society like us, we want to know how things work.
Absolutely,
okay?
Curiosity.
So, but NASA also delivers absolutely crucial infrastructure for an advanced technological society like us. I already mentioned protecting all the satellites we have in orbit.
Absolutely.
And also NASA provides all the technological development and infrastructure for the rocket launches. So by now private companies like SpaceX move into this business, but without the infrastructure and technology from NASA, they couldn't do that.
Absolutely, yeah. And you talked a little bit about the commercial aspects to it. It's not just the jobs that like provided for the scientists, the mathematicians, the engineers. It's also the insurance companies, the outside companies that gotta come up with this research and help NASA get that. Can you talk a little bit about that?
Yeah. So if you are a space company and a satellite operator, and you launch a satellite, already mentioned, we talk about very expensive pieces of hardware, several hundred millions of dollars or several billions with a B of dollars. And if you lose this satellite because it's destroyed or severely damaged, it pretty much wrecks your company.
Yeah.
So that means every satellite operator will insure the satellite. And the insurance companies need to make a risk assessment. So how likely is it that space debris is going to hit one of these satellites? And to make this risk assessment, to decide, well, are we going to insure the satellite at all, or is that a too risky business for us? Because obviously the insurance company doesn't want to pay $1 billion.
No, yeah, that's
or what are actually insurance rates? So it's like, in a way, you have flood insurance, and the insurance company will look first, well, how likely is flooding in your area? And then determine what is your insurance rate.
Yeah.
So it's I think it's a decent comparison there. And so in the future, the number of space debris particles will go up. More satellite launches. Also, the whole atmosphere is shrinking due to climate change. So space debris stays longer in orbit. At the same time, we will have more and more satellite launches. And the number of space debris particles, marble size or bigger, will actually go up much faster than the number of satellites.
Yeah.
In the end, that means the whole probability for catastrophic collisions, catastrophic damage to satellites will go up, and up over the next 10, 20 years. There's no way to avoid that. And to better understand the fundamental physics, to make the connection to my own research there. So what actually happens around 400 kilometers is absolutely crucial to develop predictive models for these collisions, and that's what the insurance companies want to have.
Okay. Yeah, they want to know.
They want numbers. So a satellite has a predicted lifetime of 10 years. So what is the probability to be hit? Is it 1%? Is it 0.1%? Or is it 0.0001%?
Okay.
Or whatever?
Yeah, and that will allow them to adjust their rates based on.
Exactly,
Okay.
to allow the rates. And so the bottom line is the National Academy of Science conducted a study about the commercial value for every dollar invested or spent for NASA. What do we actually get back as a society, as a taxpayer? And it's approximately $10.
That's
so for in terms of commercial value and all the jobs that are related to that. So in my strong opinion, this is a very, very good investment we actually do in NASA, both in terms of space exploration, our curiosity, and most people simply find that cool.
Yeah.
Okay, sending a satellite to Mars or to Jupiter.
Oh, yeah, awesome.
That is really cool.
Yeah.
That's but also for maintaining and securing our whole space infrastructure, our whole technological space infrastructure, and all the jobs that are related to that.
Mhm.
So I think reducing the NASA budget, we would shoot ourselves into our own foot.
Mhm.
That's so. Of course, I'm aware of the ongoing debate about
Yeah,
budgets
absolutely.
and science spending. So increasing the budget, well, as a scientist, I would be fully supportive of that, but I think one has to be realistic that this is unlikely
To happen, yeah.
to happen. So in the end, if we can actually maintain the NASA budget over the next few years at its current level, inflation adjusted, that can hopefully happen. But
Okay.
really reducing it would be a mistake. And also, if you look into what other countries do,
Mhm.
that's U.S. space program and U.S. science is still top-notch.
Mhm.
Was top-notch in the past, it's still top-notch, but the gap is closing. So
Yep.
if you look into, for example, how much money the Chinese invested over the past 10 years in building their own scientific and technological infrastructure, in particular their whole space infrastructure.
Mhm.
It's an incredible pace what the Chinese have.
Yeah,
So,
absolutely.
and the gap is really closing. And so if we really want to stay ahead of the field, ahead of the crowd, we better do something.
Yeah, you went ahead and answered that. The next question I had was, from being Germany, it was interesting to hear your opinion of how, the United States compares in scientific innovation and advancements in that field to Germany and other countries. And like you said, we've definitely stepped down, especially from the space race.
Mhm.
We definitely stepped down, and other countries are catching up. Like you said, China. And
Mhm.
could you talk about Germany a little bit?
Yeah, so again, I don't want to talk about too many numbers.
Yeah, I got you.
Here. So the basic research funding systems are a little different between the US and Germany. So in Germany, pretty much everything comes from the federal government.
Mm-hmm.
Percent-wise, from gross domestic product, Germany spends more
Mhm.
than the US, not in absolute numbers, but in terms of percent. On the other hand, in the US, there's also a lot of privately funded research, so it's a little difficult to compare. So Germany did and does also top-notch fundamental research there. Overall, talking about space exploration, my own field, the United States are still ahead of the crowd. But
Okay.
also ESA, so the European Space Agency, is also catching up.
Yes, sir.
That's,
Yeah, well, awesome. Well, hey, thank you so much for
okay,
coming in today.
my pleasure.
Yes, sir. Thank you.
Yeah.